The semaphore provides a solution to critical section problem. Okay, so here the semaphore defines two things. First one, an integer variable s. It defines an integer variable s, that is the number of shared resources. Okay, shared resources. The next one, it defines two functions or two operations, that is wait operation and signal operation. Okay, so this particular semaphore variable s is modified only by either wait operation or signal operation. No other operation or no other function can execute this particular wait, that is modify this particular s value. Okay, so there are two types of semaphores. First one, binary semaphore. Second one, counting semaphore. Both the cases will use a variable and these two functions, wait and signal. So this wait and signal will use the argument, that is semaphore variable. Okay, first we will see binary semaphore. Okay, so this binary semaphore is used only when there is one shared resource. Okay, so if there is only one shared resource, we will use binary semaphores. Okay, so that means we'll use to lock this particular processes. Okay, so usually these binary semaphores are used as mutex locks, mutually exclusive locks. Okay, so the range of this particular binary semaphore, that is s value, will become either 0 or 1. Okay, right. So it is used when there is only one shared resource instance. Okay, so the implementation of this wait and signal, as wait is a decrement function. Okay, wait is a decrement function and signal is considered as increment function. Okay, wait is a decrement function and signal is an increment function. Let us take this one. S value is initialized to 1 because there is only one shared resource. Okay, so while s less than or equal to 0. Okay, that is, let us take, there are three process, p1, p2, p3. Same thing if you take round robin fashion. Okay, so if you take round robin fashion, one or two instructions can be executed at a time. And remember that this wait and signal are atomic operations. What is mean by that? They are atomic operations. That means all the statements inside this particular wait and signal executed at once. Okay, so let's see p1. Let's see p1. P1 executes wait function first. Okay, now it will see that s value equal to 1. Initially s value equal to 1. Now it will execute while 1 less than or equal to 0. This condition is false. If you see this one, is 1 less than or equal to 0? No, this condition is false. If this condition is false, then only the while loop will be broken and goes to next statement and execute s minus minus. Now when p1 executes s, now it will become 1 to 0. Okay, s value will become 0 and use this particular shared resource. Assume that it is executing a printer, it is taking printing operation. Now after this one, okay, it is this particular p is currently using printer, so s value will become 0. Now at this particular time, if p2 executes wait function, p2 executes wait on s, what the value of s? 0. Now check, if you check here, it will take that s value while 0 less than or equal to 0, yes, true, the value equal to true. So there are no statements to execute. Again what will happen? The condition is true, while loop will again execute 0 less than or s less than or equal to 0, and again it will continuously execute until and unless this particular s value will become 1. Okay, so similarly p2 also, after the round robin time, p2 will come out and p3, still p3 executes s value 0, 0 less than or equal to 0, true. Until this condition is false, it cannot execute s minus minus. Okay, now what will happen? After some particular time, p1 will use the printer and execute the signal. Signal is also atomic function. In the signal, the value of s equal to 0. Now what we are doing, we are incrementing s value to 1, and it will leave, p1 will leave and executes its remainder section, then now p2 will go and executes wait on s. Okay, what is wait on s? 1. Now it will see that 1 less than or equal to 0, condition false. Now it will execute s minus 1, because condition false, it will come out of the while loop. Now it makes s value 0, it makes s value 0, and it p2 executes printer, and it will come until it uses the printer and come out and execute signal and make s equal to 1. This p3 cannot execute. Okay, right? So here the points that we have to note here is, wait is a function that provides mutual exclusion. Okay, right? So signal is a function that provides which process has execute next and when that particular process will execute. That is, it will provide the properties of bounded waiting. Wait is a mutual exclusion function. Okay, there is a condition that if that particular condition is broken, that is while condition is broken, then only it will allow the next process, the process to use the resource. Okay, so the problem here is that the process will go to busy wait when s will become 0. Okay, s will become 0, the process keep on executing while loop, so it's a waste of time. The process keep on executing while loop and it's a waste of time. So what we will do, instead of executing again and again this particular while loop only, okay, we'll use two functions called block and wake up. Okay, block and wake up. Okay, we'll see that particular thing in the next. So this is binary semaphore. Binary semaphores are used when there is only one shared resource instance. Okay, right? If there are multiple shared resource instances are there, that means if there are three printers or three or four printers are there, two or three scanners are there, or three or four shared files are there. Okay, so if there is only one shared file, we'll use binary. If there are multiple shared files, we'll use counting semaphores. Okay, this counting semaphore, the range is more than 1. The range is more than 1. Okay, so it is used when there are multiple resource instances available. Okay, so now the semaphore s will be equal to the number of resources that is currently available. Okay, here also we'll use two functions, wait and signal. Whenever you wanted to use the resource, you need to invoke wait function. Okay, after using the resource, you need to invoke signal function. So the critical section is always in between your wait and signal function. Okay, that is a shared resource. If you want to use the shared resource, you need to first invoke wait, then you need to invoke signal. Okay, so here it is, suppose that if there are three shared resources are there, that is three printers are there. Okay, so process p1 will invoke wait, so s value will become 2, that means it use one printer. Okay, then process p2 will invoke wait, and the second printer will be used, s value will become 1, and process p3 will use wait and s will become 0. It is using third printer, so printer 1, printer 2, printer 3. Three printers are used by process p1, p2, p3, but the next process p4 will try to use the printer and execute s value. So s value will become -1, that is less than or equal to 0. This is less than 0. Process p is less than 0. Okay, so whenever the process, all the resources are done, okay, used by some taken by some particular process, and the next process will invoke the wait function, that will be added to a list. Okay, a list called waiting list, called waiting list. This waiting list means the process p4 will be added to blocked list. It will be blocked by using a function called block function. Okay, right? So let's see the implementation of this particular counting semaphore. In the counting semaphore, we need to have a value, okay, that is equal to the number of shared resource instances. Instances means the number count of that particular instance. We have seen printers are 3 or scanners 4, then this value will become 3 or 4. And we need to take a list, that is a structure, that is called a list. This list represents the blocked processes. Okay, this list represents the block process. That means whenever all these three printers are taken by three processes, then the fourth process will be added to this particular blocked list. Okay, this particular block list. As usual, here the s value, okay, it is a structure. Now the value of s minus minus, so first we need to check this one, value of s minus minus. So now consider that process p1 has taken printer 1, process p2 has taken printer 2, process p3 has taken printer 3. So when initially value equal to 3, when process P1 takes the printer 1, the count will S of value will become 2. Now this, after process P2 takes the printer 2, S of value will become 1 and S of value will become 0. Now look at here. Okay. So when process P4 execute wait function, they have to execute wait function. Okay, now if they execute wait function, they keep on reducing this particular value. Okay, now at this particular point process p4 wants to execute the printer, but there are no printers are available. So what will happen, the s value will become, s of value will become -1. Now look at here. Now for p4 it will execute wait function -1 less than 0. Yes, -1 less than 0. So the first process that will enter into list is P4, because it will be blocked. Okay, it will execute block. Then the next process P5 again execute on the same wait function. It will reduce -1 to -2. Now the s of value will be -2. Again it will check -2 less than 0. Yes, then it is also goes to block list by using block system call. Okay, block call. Then assume that P1 has finished its execution and release printer 1. Finished execution and release printer 1. It has to execute signal function. So what signal function do? It's an increment function. So what it will do? It will reduce the value -2 to +1, that is -1. Then what is the value of s? S of value less than or equal to 0. Yes, -1 less than or equal to 0. Remove a process P from the list. Okay, remove a process P from the list by using wake up P. That is, P4 will be wake up, P4 will be removed from blocked list, and P1 printer 1 will be assigned to P4 process. Okay, then again P5, then again this particular next process P2 releases printer 2. Okay, then the value will become -1 to 0. Again it will check, is 0 less than or equal to 0. Remove process P from the list. So P5 will be removed and allocates printer 2 to P5. Okay, now look at here. Here also wait function is acting as gives the property mutual exclusion, and it is wake block, and remaining process will be block to block list. Whenever a process executes signal, the first process in the block list will be assigned to the resource, will be given the resource. Then it will wake up and gives the resource, wake up and gives the resource. This is how block and wake up is executing. Okay, block and wake up is works. Okay, so this is counting semaphore, this is counting semaphore. See, this block and wake up are used to avoid busy wait problem or reduce the busy wait problem. What is busy wait? If you don't use block and wake up, it is the while loop will be keep on executing. Okay, here we don't use while, if we use a if condition. If it is satisfied, then it will goes to block state, so that it will not execute the same loop again and again. Okay,